right. Well, it looks like it's 10 o'clock Pacific time, so we might as well get started with our webinar for the month. Welcome, everyone. Welcome to the March webinar presented by American Standard Circuits and Sunstone Circuits. Today, we have a great topic and a guest speaker. We will be discussing PCB123 and its applications for use in a PCB design environment. I'm Matt Stevenson. I'm the VP and General Manager here at Sunstone, located in Oregon. And today we have a guest speaker, Mr. Bob Tise, is a PCB design engineer with a company called EMP Shield. He's got over 30 years of PCB design experience under his belt, and probably one of the few people in the world that is an expert in PCB123 from a design standpoint. I know he's been using it for probably going on about 15 plus years, and has done many a design in the tool. And we're lucky enough to have him give us a great overview of the tool and how it is potentially used in your design environment. So from an agenda standpoint, Bob's got a pretty full list of things he wants to go through. The tool overview, some of the design paradigms, design methods, a little bit on parts libraries, schematics and layout, some on documentation, and hopefully then we will have time for some question and answer after that. So without further ado, I'm going to throw the mic over to Mr. Tise, and he will take us through the PCB123. Bob, the screen is yours to share.
I'm here. Well, thanks for having me on, and let's see if I can get this to actually share. So again, thanks for having me on, and I will try and get through as much of this list as I can. There's quite a bit of stuff that I plan to talk about. First off, PCB123 is got some real advantages in the design environment as it relates to working with Sunstone Circuits, because it's tied directly to Sunstone Circuits manufacturing capabilities and pricing models, and you can actually see the price that you expect to pay for your boards through their quick turn product line right there on the screen as you design. So if you do something that suddenly drives up the price of your board, you can analyze what's going on and tweak it a little bit to get rid of that price hike or decide to keep it. That's it's really pretty useful in that regard. Ease of use, it takes a couple of days to figure out the ins and outs of the tool, and even after 15 years, I still find little things that I can do that I didn't even know were possible. But it makes it pretty nice. And without beating that horse to death, let's move on to actual use and how you can use the tool to get your boards done. It's a couple of different paradigms you might go through when you're doing a board. If you're a hobby user, somebody designing a part for use in your little garage robot, or making a turn signal board for your classic car, or that type of thing, where you don't really need corporate documentation or any real proof of the design. What you can do is you can just say add footprint, and you know what part you want to use because it's a simple design. Let's say I want to do a resistor 1206. You get a list of 1206s. This is a capacitor, 1206. You just click on that and drop it on the board. I'm going to do a couple of them so I can demonstrate how to hook it up. So what that gives you, it gives you the ability to place parts quickly, and without, you don't have a part number, a specific part number you need to use. You just know that you want a resistor, and you'll tailor that as you go. I want to hook the wires up, so I tell it I want a connection from here to here. Escape. I want a connection from there to there. This is nothing you'd ever do because it's not really a circuit, but I'll be able to show you how to hook it up using the connections. And basically what I've done is I've just made a loop through those parts and hooked it up. And it's that simple. Depending upon what parts you want to use, you can throw a connector at one end and a light bulb at the other, and hook it up to ground somehow. Off you go. And then it tells me that if I order 20 of these in 3 weeks, I'm going to pay $22 a piece for them. But this board is 5 by 3 inches. And if you make it smaller, it's pretty easy. All you have to do to make it smaller is just click on the corner and drag it over, and then change the shape of the board, the size of the board. What do you want to do? You can make it round. You can put radius corners on the board. It's pretty easy. Just tell it you want a 1-inch radius on that. Boom, I got a 1-inch radius. Very, very easy to use, fast, quick and dirty if you want to do it that way. And you can get a board, as quick as Sunstone can make it. Now, and again, you're not going to have a schematic. You're not going to have a bill of materials. The bill of materials is going to say, I've got a capacitor. It doesn't give you the ability to just simply order the thing. It gives you a schematic that's pretty ugly. You won't be using it to do a whole lot of tracing of the circuit, but it's there. Now let's move on to somebody that's got a company that they're trying to get a product to market, and you're going to need to maybe patent it eventually, or be able to hand it over to your engineers for troubleshooting and modification later. Let's get rid of this guy and go to a little LED board. Now this is just an LED board that I did for one of our products, and there's not a lot of company secrets here, so I can share this a little bit. On this board, it's got again, it was done just by throwing down some parts and hooking them up in the circuit board. Gives me names here and parts here. These parts are again just a generic part, just an LED 5mm, and it's got a connector. So not a lot of secrets there. Pretty easy. Then we'll go on to this other board. There's something here that you're not gonna be able to do this level of complexity with just making your interconnect on the circuit board. So I had to do I chose to and needed to do a proper schematic. This is the circuit diagram for this thing. Every part's got a part number, DigiKey part number, a manufacturer's part number. It's all traceable to what's going on there, and this bill of materials can be dropped into DigiKey and ordered directly from this bill of materials using their automated feature. So you don't have to go enter every part number by hand or go through all that tedium. You can check to see part availability just by basically running the BOM through DigiKey. Let's say I need to add a part that isn't on my schematic already. So I would go up here and just grab the add part button and enter a part number or some string that works. 200K resistor. Boom, it gives me a list with 200K resistors. Then I can go to DigiKey, look to make sure that if, you know, one of these resistors is available in any quantity that I might need before I just place it on my board. That will allow me to build a board that I can actually get parts for. And that's for that. Now, let's say I have a part that isn't available from PCB123 at all. It's just not in the library yet. I can either make that part. It's, you know, some parts are easier to just make and on the fly and do. So I would go back to the layout. I would make a footprint for the part using the manufacturer's data sheet. Then I would go to the schematic, make a schematic symbol using, again, the same data sheet and make the symbol so that it represents the part. And here's an example of a part that I had to make, this optocoupler. And then make sure that pin numbers are correct, the part orientation's right, and the interconnect between the two works as designed. And then I go up and say, manage parts. And then I select the symbol that I just created, select the footprint that I just created, copy and paste the manufacturer's part number, the part name. I'm sorry. Oh,
Go ahead, Bob. It was somebody's.
oh, okay. So then I just paste the information necessary here, paste the description straight from DigiKey or wherever, right here in this window, and it populates your part. Say create a new part, and bam, I've got a part I can use. If I use the manufacturer's part number to name the symbol and to name the footprint, and then add that information into the part number and such, then all I have to know about that part is that it is a, for example, TCMT 1600. And anytime I want to place that part, I just put down, I enter that string into the search, and it pops up. And there, I've got it. That's the different part, and that's the part we've got on the board. So place them, hook them up, make sure your schematic's neat. It's always really good to try and keep your schematic a little bit more spread out so you can follow the lines. You don't want a super crowded area. And like this area in the middle here, it gets pretty crowded where I go to these two connectors. And it's the bigger it gets, the harder it is to follow these lines. But it's nice that you can highlight each individual net and follow it, trace it to where it goes. It allows that. The after you get your schematic done, of course, you'll go back to your layout editor, and all of your parts, once the schematic's complete, all your parts will land piled up into a stack on the origin. You'll need to move them around and place them on the board logically and per the schematic. And the way I do that is I just take all the parts from this location and just spread them out off the board. I zoom out a little bit and I spread them out, like in this area, so that I can see all the parts that I've got. And then I'll take a paper copy of the schematic. I'll just print it out to whatever size I can see the reference designated, and I'll select the parts by reference designator and move them to where I think they should go. So to select a part, you just type an F to find, and then you enter the part name. Let's go with something easy. R10. That puts your cursor right on the R10. You can zoom in on it, take a look at what's going on, and then move it where, place it where it goes. You'll have guide wires on all of your parts to tie them all together, but when they're spread out randomly from before you place your parts, it'll be pretty hard to follow. And it's kind of a dynamic thing. If you move a part to another location, if it's connected to more than one place, that connection might change to that other part. So you can't really just say, oh, the guideline wires go from here to here, so I'll just hook them up by that. It's better to use your schematic to drive the placement of the board. And I try and do my schematics sort of along the lines of how the circuit board's going to be laid out, so I can have some correlation to that. But it doesn't have to be, you know, you can't do it exactly, but it makes a lot more sense that way. And then again, you can modify your board to fit the necessary physical parameters. This is 2 circuit boards that plug together with a ribbon cable. So I put a slot here so I can just, you know, clip the 2 boards apart and off we go. And this red features a slot. This is a cutout. We can cut the, you know, it fits over a boss on a part. So basically it goes like this. You set up your board outline to fit in whatever enclosure you're going to go with. You select your part, you know, your schematic parts, do your schematic, then you go into here, you place the parts, you place them logically so you can route, then you'll have the guide wires. And then you want to route your wires. It's pretty, the way I go about it when I go to route a board, I like to route the power and the ground and make sure everything there is hooked up. Then if I've got any clocks or critical high-speed wires, I hook up those to make sure that that there's room to get them hooked up and logically laid out in a way that they're not going to be interfered with by other things. And then I go in and route any other non-critical nets, just, you know, basic interconnect stuff like this area here there's really no high speed to it. They just had to hook up. So and you can see that there's some stuff like this power stuff is routed fairly carefully at the nice wide traces. All that stuff is customizable. If I want to change the width of a wire, I just change it, type the W and say I want it to be 40 thousandths instead of whatever it was. Since it's a power line, I want it fairly wide. And then if you want to undo something, Control V, Control V, Control V, as many times as you need to get back to something that looks right. So if you do something you don't like it, you just do undo until you get back. Another feature that the tool has that's very nice is the ability to put in power planes and then route around them. And so long as they're hooked up to the correct net, and you get clearances that are appropriate. This is a pretty high voltage board, so I give it pretty large clearances around some of the wires that allow it to not arc or to be interference. You can also do inner plane layers where you know, this is a 4-layer board. You could do inner plane layers that just automatically connect to, like if you want to ground and a power, you can do that. You can do split planes. That's probably not recommended with this tool because, well, with any tool really, where you have 2 different voltages on inner layer, simply because once you define a layer to contain those two different voltages, you're required to keep track of that in your head because it will hook. It doesn't keep track of which half of your board is 12 volts and which half is 110. It just knows that 12 and 110 go on that layer. And putting a split down the middle, if you miss one of those 110 connections and it stays on the 12 volt, you're going to have a really exciting day. Then that's not a good thing. Now let's say you get to the point where the board is pretty well laid out, all connected up, everything's good. Go up, hit the design rule checks, hopefully this comes up clean. And this has basically nothing I really worry too much about. Two unconnected net editors because I've got two wires that go from here to here, but they don't actually, the same net name, they don't actually tie together because of the slot. Component overlap errors, and that's a pretty common thing to have because the reference designators are considered part of the footprint, and it doesn't, you just can't make it not do that. But you go check it out, make sure you don't have a part laying on top of another part. And then text on the mechanical layer, who cares? Non-plated holes too large. Okay, I want those holes that big. And then you just go up and hit the order button. You hit the order button, it takes you directly to the order form, and you make any edits there that you want to make and order some boards. Off you go. And the beauty of it is it just takes you directly to the order form and lets you log in and get your boards ordered without any, you don't have to make a package. Like a lot of tools, you have to put together a package. You have to generate your own Gerber files. You have to, check to make sure that when you generated your Gerber files, you didn't really mess them up. You just send it off. And the team at Sunstone takes it from there. And if they have any questions, they'll always send you an email or give you a call to make sure that everything's the way it should be before you get your boards. Now,
Hey, Bob,
yes,
quick question. Someone asked us if you could do differential pair routing.
that's a manual thing. You can, and I've done quite a bit of that. So it's not hard, but it is, and you can check the length of wires to make sure that you're not too far off. You just go, you highlight a wire like this, type of P for properties, and it shows you the trace width via pad, via drill, tracks, routed length, 1.413 inches. So you can, and then if it's too long or too short, you can go in and wiggle one or the other to get the right length. And it goes pretty fast, really. It's not, I mean, it's not like using a tool like Cadence or Metagraphics where you tell it you want a differential pair and it manages that for you. And you certainly wouldn't want to auto route. Matter of fact, I wouldn't want to auto route pretty much anything using the auto route tool. Sometimes I'll use it as a reality check. Do I have enough room on the circuit board to actually do the design? And if it can auto route to 80%, just hitting the go button, then I pretty much know that I've got room to do it. Otherwise, I go in and wiggle things around, get a little more room. But again, differential pairs are they're easy to do. They're just not. It's not an automatic function. So again, when you're making your board, you can make your own parts. It's not hard. It does take some practice. You need to know the rules around manufacturability, pad sizes in relation to the actual physical part, that sort of thing, spacing rules, all of that. It's that sort of thing is something that you learn as you work over the years. You get better at it to the point that you don't even really the math just is in your head, But if you don't know those rules and you just want parts to use on your board, you can order those again from Snap EDA, which is an online library service. A lot of times they'll have the part already in the library, and if that's the case, the part, it'll be free. If you don't find the part you're looking for in Snap EDA, what you can do is just order a part, and there's a little fee for that. But typically, when you're ordering a part, it's a little bit more complicated part than just a resistor or a capacitor. So the time that you save in having them build that part for you is worth the 30 or 40 bucks that it costs to make the part. And that wasn't an ad for Snap EDA or anything like it. It's just a reality that I live with pretty much every day too. Time is money.
do you want questions as we go, Bob, or do you want to wait till the end, or
Yeah,
I've got a couple?
Yeah, we can do, if you've got questions, I can go there.
Okay, so here's one. If, for example, I place a footprint for a DIL socket, the BOM does not reflect the price of the expensive processor chip it should hold. Is there a way around that?
Yes, you have to either make the part using the correct DigiKey information, or you can have Snap EDA make it for you and use that part. If you just place the footprint on the board, it won't have any part number information. It won't be intelligent per the schematic. It's just a footprint. So you'll need to use the schematic function, place an actual component with the part number and all that information attached to it. And a lot of times you'd be surprised the parts that you're looking for will already be in Snap EDA's library or selection. You can just go search for it and place it that way.
Okay, and one more. Can we add mouse bites from the software?
And you add mouse bites from the software. Well, what you can do, so you're talking about panelization for to be able to snap it out.
Let's see.
You can order that and say I want tab route with perfs in the order form, and it will, and the team will build the board with mouse bites. Now, for example, this feature that I built right here with the big slot, so I can break this apart. If I wanted to add mouse bites to this, I would just go up to the add a pin and tell it that I want it to be non-plated, and I want a 26 mil hole, and I throw half a dozen of them in there. That's gonna snap off really clean and really nice now, right where I want it. I won't have to cut it. What you risk by having something like this is if I was gonna just snap this off now, and I had like a surface mount component right here that was fragile, like a capacitor, a ceramic capacitor, or diode, something along those lines, and too close to this. When I go to snap it off, the board bends a little bit. You can crack those parts, but the truth is it's that easy to put those in. You want to make sure that they're far enough apart that they can be manufactured. If they're too close together, then you will they'll just delete the drills because they're too close together. They won't they'll snap drill bits, and they won't do those holes. So I think the rule is 10 or 15 mils apart for any holes. If you make them that far apart, you'll be pretty safe. Now, a couple of things that you can do. I've got our design engineer likes to see what's the board really going to look like in the real world, and you can look at kind of what it's going to look like in the real world by going to this 3D view, and it's going to have a few parts on the back, and copper plane on the back. On the front, you can see the circuit, how it's pretty much going to look. Now, this isn't an exact 3D model that you could send to your machinist and say, I need an enclosure built for this. It's just a picture. You can also go to the true copper pour view. This is a different view altogether that shows you what the Gerber files are going to look like, and all of your layer controls this is exactly what the Gerber files are going to look like. So all the clearances are in there, all the places where the the clearances overlap, because sometimes your board that you're looking at in the actual layout editor may have features that are slightly different when the Gerbers are drawn. It's just part of the tooling process, and this takes into account what's going to happen in the tooling process. What I can do is I can go in and if nobody minds, show you how to make a footprint. It's really pretty simple. I always start with a part that's already there. Let's say I want a surface mount electrolytic capacitor. I've got one here, so I know that shape is kind of what I want, but I want it to be smaller and have smaller pads. So I'll say edit footprint. That's this selection right there. It'll pop another window altogether. And then I'll say, okay, these pads are too small or too big. Just select them. Look at the properties for the pad. And I'll say I want them to be 25 by 0.3. Why not? Make them smaller. Oh, and they're the right distance apart. I still like that. But this outline of the part, the little plastic pad that it sits on, it's too big. The part that I want is going to be smaller. And I don't have a data sheet open right now, but let's say I know that it's going to be about that big. It's pretty easy to modify. And you set your, if you know the size you want it to be, and for example, this is 0.3 by 0.3 from the center, and you set your grid to 0.1, and you can just count the grid points up to find that location and plug it down. If you want it exactly on some point, you can set your grid to whatever that distance is and put it exactly there. So if I want this to be 0.315, just click on it and it goes to 315, and that would be 0.66 or it's 0.63 width part. But it's fairly quick and easy to make the part. And then what you would do is save it with the name, and I would call this part right now is it's just a capacitor 1816, but it's not anymore. It would be a capacitor something given by the manufacturer. Data sheet would tell you what size this is, or you would just give it the part number. It would be CRCW blah 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 with a big long number afterwards to tell you that it's this specific part. Then you go to and I'm not going to go ahead and make this part because I don't need it in my library. You do a file, say footprint as, give it a library, PCAPs, give it a name and a description, and save it, be done. I'm not going to do that. And that's gone. Then you would go to your schematic. And again, for that part, I would just use a polarized capacitor symbol to make it. and tools, manage parts. And again, I would just select the symbol. I gave it a name, CRCW, something or other. Sure, I'll use that one. And down here for the footprint. And I like that. That's a lovely part. And then enter some stuff here. Epsilon plus, and the DigiKey part number and description. And then I would go down and click create new part, and it would put, I'd tell it what library I want it to go in. And since this is something I'm building, I would put it in generic capacitors and hit the go button. And if you don't hit this create new part, you get to do it again. This is the I miss this button on every third part I make. I have to do every part, pretty regular. I do it twice, but it's easier the second time. So cancel that, and I'm out. It's basically that simple. The more pins you have, the longer it takes to make a part, and again, it's sometimes frequently much easier to just pay the service to have it done. And I'm ready for questions.
Here's one, Bob. Can copper thickness be defined individually for each board layer?
No. That takes a phone call. And I'm pretty sure Sunstone doesn't offer that as a standard surface or a standard service. The options that you have are 1 ounce, 2 ounce, or 3 ounce. And the material thickness, the options you have are 31 thousandths and 62 thousandths for this particular 4-layer board. I do know that you can order different thicknesses. Again, you'd have to send an email or call Sunstone and get their sales folks, and they'll be able to walk you through how to make that happen. And I do it all the time. I get boards that are different thicknesses. I have, I believe, on one occasion wanted to get thinner copper on the inner layers and 3 ounces on the outers, or vice versa. I can't remember exactly the details. We did it. It was fine. The boards came out just fine, but it wasn't. It's not something we actually went to production with, and it really wasn't necessary for the boards to work. Again, if you're running a lot of power and you want to get through, you want to get those heavy layers on the inner layers, you can do that, but it's still going to rely on the thickness of the traces on the outer layers, so it's not always that important.
Okay, here's another question. How do I make a cutout inside the board area?
That's a killer there. Stone made that pretty easy. This button right here, create cutout. You can either do a circle or a rectangle. I already have a circle on there. Let's do a rectangle. And I've got an area right here that lends itself well to that. And I missed the corner. I'm going to go fix it. Well, it's not really select that corner. Well, that's embarrassing. Sometimes it gets like that. It just flat won't let you select the corner you want to select. So,
I have a couple more questions when you're ready.
okay, I'm ready. I don't like this. Kind of
I know how to add text and basic shapes on the silkscreen layer, but could I add more complex shape like Rojas or a company logo?
I've done that. The way that I've made that work is I create a bitmap in Paintbrush. Basically just copy it or copy my logo to Paintbrush, and then I get rid of everything I don't want, and then I save it to a monochrome, so it's just black and white. And I'm not sure if you want it to be the negative image or the positive image, if you want to fill the thing with the image, but then I import that into the tool using it was more involved than that. I had to import the graphics into a Gerber editor and then save that Gerber and then import that into my board file to get the actual image I wanted. It was a pretty involved process. I got pretty good at it when I was working at Sunstone years ago, but if you don't have an actual Gerber editing tool, you probably won't be able to pull it off. Did that answer the question at all?
Well, let's see. I've got a couple other questions. He said yes.
Okay, good.
How's a cutout different from a slot? I've entered slots by placing a pad, but not used the slot trick.
Okay, so slots are just basically a pin, a non-plated pin that's defined using the add pin button. And a cutout is anything else that you want to cut out of the board. They only let you do rectangles or circles in the cutout command, and you can't do, for example, you can't do a cutout that has six, has an L shape. You probably could lay one over the top of this to give you an L shape, but you can't have a cutout that is an L shape. I could do that. And the error is hard. It doesn't like it. So oh, that's just a polygon. I'm sorry, that's just a polygon. So so I've overlapped this and given it a funny little cutout here, and it'll let you do that, and I believe it will cut that out and give you the thing. So cutouts you can be kind of versatile with them, but slots, what you can do is you can take another slot I should stop drawing it. If I wanted another slot to run horizontally across this, what I could do is slot. And just rotate it and just throw it on there and basically cut my board in half. So, and this is completely editable. You can change this now. Let's say instead of making it, oh heavens, 26 inches long, I really only wanted it 2 inches long. And so that's how slots work. And basically, when they're drilling the board, they just drop a drill bit that size or a milling bit and route along there, and you've got a slot. And they do the same here. They drop it here and run it this way, give you that slot. Cutouts, I think they do that the same time that they do the rest of the drilling. If that answers the question, there's really no difference in how they're created. They're just two different ways of defining these features. And this will give you the ability to make a, you can make this a zigzag for creepage, high voltage protection, that sort of thing. You just put 2 or 3 in here. You can rotate it to whatever angle, give it a different angle if you want. Properties, you can tell it how to rotate here, and instead of 180 degrees, I'll say 25 degrees, and it'll put it in at 25 degrees. It really doesn't like it. It also is very picky about what it'll let you do, as far as if it's going to create an error, and it was going to create an error. So hopefully that at least rambling answer give you some idea what goes on with slots and cutouts. What else you got for me, Kelly?
I don't see any other questions at this time.
Okay.
Oh, here's one. I don't think the 2-slot demo you showed will work. I had 2 slots nearby which satisfied the DRC, but got a note from Sunstone a month ago that they were too close.
They don't like to have slots running parallel. That leaves just a little web between them, because that web will just shatter. But what you can do with a T-shaped slot, and I've done those. I know that Sunstone can do them. You may have to go through instead of the quick turn process, you may have to go through the full feature process. Let me see if I can round up one that I've done that on.
You said, okay, the T-slot makes sense. Thanks.
Okay.
Are there any other questions? Looks like we've got a lot that can be covered, and maybe we'll evaluate if we want to do another one of these, and you can weigh in if that's of interest.
go more in depth on any particular subject. One thing that I do when I route the board, using the the signal routing, is I always set up with a grid that's fine enough that I can do a nice job of routing, but not so fine that I can't ever hit anything. For example, if I want to route two things together, and I found that a 5 mil grid is pretty useful in routing stuff like this, because I can always come out of a pin that's not on a 5 mil grid, take my trace up to a grid point, and then route everything on a 5 mil grid. It comes out looking a lot nicer. I always route using 45s on my corners. I don't like 90-degree corners because it's harder to hit. It's harder to make that connection at the corners with a 90, because you have to come up and find that exact point. So 45s are also good. They have a lot of benefits electrically, as far as reducing reflections on the higher speed lines. Yeah, we can later on we can go into more depth on specific subjects if you've got something. Hopefully I didn't ramble and get totally confused on too many things.
All right. Thank you, Bob. Thank you for your insight. I think it was pretty well received. Well, unless there's any other last minute questions from the attendee group, we will wrap it up for today, and hope to see you guys again next month. All right. I don't see any questions, so let's call that a wrap. Thanks, everyone.
Oh, put these designs without saving. Yeah. Okay. Everybody's still logged in.
All right. Thanks, everyone.